Right. So we are going to solve the quadratic 3x squared minus 75 equals 0. If we have a quadratic in this format, we can actually just solve for x. The reason being, if you're taking a look at the equation 3x squared minus 75 equals 0, there's only one variable there. So I can solve and get that by itself. I can get the 3x squared alone, and then I can divide and find the square root. So we are going to work today on solving quadratics by finding the square root. So what is the function? If I were to graph this, what was the function that would have been that graph? How do we write the quadratic as a function and not an equation? Y. Yep, y equals 3x squared minus 75. If you had to envision that graph, its y-intercept is negative 75, and then you could plug in a few values for x and plot some points if you needed to. But we can solve this using square root. So only the x squared term is there. You can typically solve by finding a square root if you only have the x squared term. That b value is still not there. Okay. So we can write the equation in the form x squared equals k, basically just getting the constant by itself. Not really sure why they show it as a k, because it's been a c for so long, but we'll just run with the idea that that is the constant. So if we wanted to get x squared alone, what would we have to get rid of here first? The 75. How would I get rid of the negative 75? Yeah, I can add 75 to both sides. So my equation looks like this. 3x squared equals 75. So now what would we do to isolate x even further? By 3. Yeah, I can divide both sides by 3. So what is x squared equal to? 25. Good. And then what's the last thing I would do to get x alone? Square root. Yeah, the opposite of squaring a number is finding a square root. So if I find the square root of 25, what is x? 5. How many solutions would this quadratic have?
1. 2.
It would have 2. So what's the other solution? Negative 5. X squared. X could be 5 or negative 5. So if I had to graph that, what would it look like? If this was my equation, what are some properties of the graph that you know? The y-intercept is at negative 75, way down here. What else? It's going to open upward. Our x-intercepts are going to be negative 5 and 5. So, looks something like that. Now, obviously, my negative 75 would be way lower. But now that we've found these solutions, we remember from yesterday that our solutions represent what? The x-intercepts of our quadratic. So in this situation, we have 2 solutions. If we graphed it, would our graph actually cross at 5 and negative 5? Yeah, absolutely. And if you needed to plug in a value, if I plugged in a 5 or a negative 5 for x, this side of the equation would equal 0. So this is a great transition for solving equations from just solving linear equations, because here we're able to isolate x. We only have that ax squared term, so we're able to find the square root. How are these graphs related? Y equals x squared minus 25, and y equals 3x squared minus 75. What do you mean? They have the same solutions. Good. So they're going to do what? They're going to cross at the same points, but what's different about them? So what will it look like compared to that one? Which one's fatter?
The y equals 3x. The y equals x.
What makes it wider or skinnier?
If
If a smaller number, a smaller coefficient of x squared would make it wider. So which one's the widest? Yeah, this one is wider. It would look like that. And then what would the 3x squared minus 75 look like? It'd be skinnier. Our y-intercept would be way down here, and then it would go up more like that. So it is simplified. However, by dividing out, if you factored out a 3 here, you would get the x squared minus 75, but the difference is you're not dividing the other side by 3, so the graphs are still different. They still have the same solutions, though. Okay, so let's try to solve. You're not going to do these on a communicator. I'd rather you keep them in your notebook for now. Find the solutions for m squared minus 36 equals 0, 3x squared plus 15 equals 0, and 4d squared plus 16 equals 16 by solving for x. Bless you. Anyone help me out with A? How we're going to solve for m? Good, we can add 36 to both sides. So our equation becomes m squared equals 36. What do we need to do to solve for m? Yep, the square root. So m equals what?
6.
And negative 6. So I'll write 6. 6 and negative 6. Okay, it's important to really note that there are two solutions for that, because negative 6 squared is equal to 36. That part of the board is weird. It gets very glitchy. How about B? Okay. So what's my solution? No solution. Why is there no solution?
Because it will intersect the x-axis.
Yeah, that graph's not going to intersect the x-axis. You could tell just by looking at the original equation. Where's the y-intercept? It's at positive 15, and where's it opening? Now, if you didn't notice that, when you tried to solve it, you should have gotten to this point and realized a red flag. What's the red flag if I try to find the square root?
It's not a real number.
Right, I can't find the I'm not going to have a real number if I find the square root of a negative, because nothing times itself would give me a negative 5. So this would be the red flag. I can't square root a negative. That would be your red flag for no solution if you didn't realize it in the equation. Last one. Subtract 16, good, from both sides. So 4d squared equals 0. Divide both sides by 4. D squared would equal 0. What's D?
0.
D is 0. How many solutions?
One.
Just one solution. Right here, D is 0. That would look something like, it would be up here, where x is 0. Sorry.
Yeah.
That would be what our graph would look like. This would be 1, this would be none, and then this one would have been 6 and negative 6. There would have been 2. Now tomorrow, well, Thursday, because even if we have school tomorrow, you have an assembly for one of the periods. So we'll practice just finding square roots. On Thursday, we're going to start to solve if we have that middle term, that bx term. So far, we haven't had that to solve. Okay? So what we are going to work on now, it's 9:27. Actually, let me pause the video first. I was recording so that if we